Hello, this is Mr. Stansbury. I'm going to take you through the 4 F notes on circle problems. After this is all done, you should be able to understand the special relationship between a chord and a circle, and also be able to use the Pythagorean theorem to solve problems involving circles. Alright, so let's take a look at some important foundational stuff so that we can get this all figured out. Okay, chord. Chord is just simply a straight line that begins and ends on a circle. So here's a circle, supposedly. You just have to imagine with me. So there's a circle, and a chord starts and ends on a circle. So that is a chord. Okay. Now with that, the line that is drawn from the center of a circle. So here's the circle, here's the center, and a line that's drawn from the center of a circle at a right angle with the chord here. So in other words, it goes straight down to the chord here and makes a right angle. If it does that, it actually bisects that chord, so it cuts it into 2 equal pieces. So this chord that now at this point here, this length is the same as that length. Okay? Now, something else that you're going to need to know is a tangent. And a tangent is a straight line that just touches the edge of a circle. So here's our circle, here's a straight line, and it just happens to just touch at one point on that circle. Okay, so that there is the tangent, and it's called the point of tangency. All right. So, with that, here is also the line that's drawn from the center of a circle to the point of tangency makes a right angle with the tangent line. Okay, so pretty picture of that is this here. So here is our circle, and there's the center. And if you draw a line, gosh, I cannot talk apparently. So you draw a line from the center of the circle to that point of tangency there. It actually makes a right angle with, like, this radius here, the line that's drawn, and the tangent make a right angle. Okay, and again, that's also important to know. All right, so let's take a look at some examples. Okay, so first example we're going to look at here is example 17 from page 102, and that says that a circle has a chord of length 10 centimeters and the radius of the circle is 8 centimeters. Find the shortest distance from the center of the circle to the chord. Okay, so again, to me that's pretty overwhelming. So what I always like to try to do is I just want to draw a picture of it first so that I can understand what the heck they're talking about. So I'm going to try to draw a circle here. It's not too bad. And there's our point there. Alright, so it's got a chord length of 10 centimeters somewhere in that circle. Alright, so let's just draw one. Draw ourselves a chord, close enough, and we'll call that 10 centimeters. And the radius of the circle is 8 centimeters. Okay. Now what I'm going to do is I'm going to actually draw my radius to those chord, the beginning and end of the chord there. So there's that, and there's that, and we know that both of those are 8 centimeters. Okay. Find the shortest distance from the center of the circle to the chord. So the shortest distance from the center of the circle to the chord is this right here. Okay, that one that makes the right angle. That is what we're looking for. So now again, for me at least, it makes it a lot easier now that we have this picture here. Okay. One other important thing to note is with this here, remember from our previous notes here that when you draw this length here, the shortest distance from the center of the circle to the chord, that makes this right angle. Remember now, this piece is the same length as that piece. So to figure out what that is, we take 10 centimeters, cut it into 2 equal pieces, and we find that that's 5 centimeters. So now we know here that this piece is 5 centimeters. So I'm going to kind of just redraw this piece of the triangle right here so that's not quite so confusing. So there's our 8 centimeters, there's our 5 centimeters, and there's our right angle. We want to find x. So Pythagorean theorem it is. So let's do a squared plus b squared equals c squared. There's our hypotenuse. So remember, that's our c. So there's our 8 squared, and then the other two can just be our x squared and our 5 squared. So x squared plus 25 equals 64. We want to get x squared by itself, so subtract 25 from both sides. We get x squared equals, let's see, 39. So we don't want to know what x squared is, we want to know what x is, so we square root both sides. We get x equals, you could just leave it as square root of 39, right? And again, officially when you take the square root, it could be plus or minus root 39, but again, since we're looking at a distance, it's got to be positive 39. Or we can calculate it out and see what the square root of 39 equals. Square root of 39 gives us 6.2, let's go with 6.24. And these are both centimeters. Alright, so the shortest distance from the center of the circle to the chord is, let's go with 6.24 centimeters. Shortest distance from the center of the circle to the chord is 6.24 centimeters. So that's what we figured out. All right. Okay. Now, let's take a look at another example. And that will be example 18 from page 103. Alright, a tangent of length 10 centimeters is drawn to a circle with radius 7 centimeters. How far is the center of the circle from the end point of the tangent? Alright, so let's draw another pretty picture. Here's our circle. Here's the center. So tangent of length 10 centimeters is drawn to a circle with radius 7 centimeters. This is not super well worded, but what they mean is, here's the tangent point, and then you've got this line here that is 10 centimeters. And then it also says that the radius of this circle is 7 centimeters. So let's draw that straight down to this here. And that's 7 centimeters. We know from before that that makes a right angle. So it says how far is the center of the circle, so this here, from the end point of the tangent. So again, we have to assume that they're talking about this end point here. So we've got to figure out what this is right here. Alright? So back to Pythagorean theorem, a squared plus b squared equals c squared. Again, our hypotenuse is the x. And so we'll use 7 and 10 for our legs. So So 49 plus 100 equals x squared. So 149 is x squared. Take the square root of both of those to figure out what our x is. And again, we can have it as just square root of 49, or we can also, again, calculate that out. Square root of 149 gives us 12.21, or 12.21, and this is all in centimeters. Okay, so again, they were asking how far is the center of the circle from the point of from the end point of the tangent. So it is 12.21 centimeters from the center of the circle to the end point of the tangent. Okay, and there is our answer to this question. Okay, that is it. If you have questions, feel free to ask. Thanks.